Hi, we define now the monotonic sequences. So a sequence can be, of course, increasing if all the terms are increasing. So it means that any term is greater or equal than the term before. So a sequence is increasing if all the terms are increasing. So it's if the difference between any two consecutive terms is positive. So we say that it's strictly increasing if this inequality is strict, so it's strictly positive, which means that any term is strictly greater than the term before. We say as well that a sequence is decreasing if the terms are decreasing, so if the difference between un plus 1 and un, any term and the one before, is negative. And if the difference is always strictly negative, we say that the sequence is strictly decreasing. Now, of course, a sequence is monotonic if it's only increasing or it's only decreasing, so it doesn't alternate, because we have sequences that are alternating. They are neither increasing nor decreasing. Like if we take, for example, minus 1 to the power n, it's a sequence that it's equal to minus 1, 1, minus 1, 1, minus 1, 1 all the time. So it's never increasing or decreasing all the time. That's why it's neither increasing nor decreasing. Okay, so a monotonic sequence is a monotonic that is only increasing and never decreasing, or only decreasing and never increasing. Now the theorem that can be arise from this definition is the following: if a sequence is increasing and if it's bounded above, it means that it will be convergent. Okay, imagine a sequence that is increasing, all the terms are always going higher and higher, greater and greater, but we have an upper bound that the sequence will never bypass. It means that there is at some point a limit that it will never bypass. So it has somewhere a limit which is not equal to plus infinity. Okay, if the sequence was not increasing, it means that it can go decreasing at some point, so it can go to minus infinity. So the hypothesis of a sequence increasing is essential, because we need it to be increasing to ensure that it will not go to minus infinity, or it will not alternate, at least it will stay going upwards, but there's a limit that it cannot bypass. That's why we say that the sequence is convergent. So if a sequence is increasing and bounded above, it means that it's convergent. And similarly, we can say that if a sequence is decreasing and bounded below, then it's convergent as well. Let's illustrate a little bit what's happening here. So if you choose an upper bound, of course all the numbers greater than this upper bound are upper bounds, but if you choose one of the upper bounds, okay, and the sequence is increasing, so whether it will have a limit somewhere below the upper bound and it will approach it indefinitely or not, if not, it will continue increasing until reaching the upper bound, and then it will approach it indefinitely. So it will have a limit for sure. The thing is that the limit of the sequence will be the supremum of the set that contains all the elements of the sequence. So if you take a set that contains all the un, the supremum of the set will be the limit of the sequence. Why? Because the limit of the sequence is defined as being a number that we are approaching indefinitely. So it's of course an upper bound in this case, and then if you take a small interval around L, so if you position yourself at L and you go back like for an epsilon, so if you take the interval L minus epsilon and L, of course you will have terms of the sequence inside this interval because of the definition of the limit. So the limit L in this case, it satisfies the characterization of the supremum. That's why the limit in this case is the supremum of the set. And if the sequence is decreasing towards a limit, then the limit in this case will be the infimum of the set of the elements of un. Let's take an example. So if we need to prove that the sequence sum k going from 1 to n of 1 over n plus k is convergent, we have first un plus 1 minus un is equal to un plus 1, it will be the sum k going from 1 to n plus 1 of 1 over n plus 1 plus k minus the sum k going from 1 to n of 1 over n plus k. So the first sum will be equal to 1 over n plus 1 plus 1, so it's n plus 2, plus 1 over n plus 1 plus 2, it's n plus 3, plus 1 over n plus 4, plus etc., plus 1 over n plus 1 plus n, plus 1 over n plus 1 plus n plus 1. Okay, and then the second term will be minus 1 over n plus 1 plus 1 over n plus 2 plus etc., plus 1 over n plus n. Let me add an additional term in here, plus etc., plus 1 over n plus 1 plus n minus 1 plus 1 over n plus 1 plus n plus 1 over n plus 1 plus n plus 1. So therefore, when we do this difference, what we will obtain is the following. We will have n plus 2 that will be cancelled with this n plus 2, because of course here I didn't write it, but it's minus everybody in here. Okay, so n plus 2 will be cancelled with 1 over n plus 2, 1 over n plus 3 with 1 over n plus 3, 1 over n plus 4 as well, and then you have 1 over n, which is this term, 1 over n plus n, sorry, it will be cancelled with 1 over n plus n in here. So we will finish having only two terms, 1 over 2n plus 1 plus 1 over 2n plus 2 minus 1 over n plus 1, which will be equal, when doing a common denominator, it will be equal to 1 over 2n plus 1 times 2n plus 2. And this term is positive, then un is increasing. So we need to prove one thing more, is that un is upper bounded. Well, we know that un is equal to the sum k going from 1 to n of 1 over n plus k, which is less than the greatest term of this sum, which is 1 over n plus 1, times the number of terms, which is n, and this is equal to n over n plus 1, which is less than 1, not equal even, it's less than 1, because n plus 1 is greater than n. So un is bounded above, therefore since un is increasing and un is bounded above, then un is convergent. Now, can we say that the limit is equal to 1 because it's bounded above by 1? No, we cannot, because when you find an upper bound, it's not sure that this upper bound is the limit. We might be overshooting. It might be greater, much greater than the limit. So all we can know in here is that un is convergent. If in the question we are asking you to find the limit, it means that most probably you'll be using something like the sandwich theorem, because it will give you the limit, and not something like this theorem. Now we need to define the adjacent sequences. When we have two sequences, un and vn, these two sequences can be called adjacent if they satisfy three conditions. First, we should have one of them is increasing, the other one is decreasing, and the difference between them goes to 0. So imagine you have one sequence which is increasing, the other one that is decreasing, and the difference goes to 0. It means that they are approaching each other. That's why we can prove that these two sequences will be approaching a limit L. So they will be convergent and they will have the same limit L. One of them will be coming from below and the other one is coming from above. And also we can prove that any term of the sequence un is less than any term of the sequence vn. So we can prove the following theorem. If un and vn are adjacent, then they are convergent and they have the same limit, and we have u0 less than un less than u2 less than un, etc. because u is increasing, and you have v0 greater than v1 greater than v2 greater than vn because v is decreasing, and the limit is between both of them. So if you really need to find the common limit, all you need to do is to calculate terms of un and terms of vn to a high index n, so that you will have a very tiny neighborhood of L given by a some un and some vn at a given index n. Okay, so if you calculate, for example, u100 and v100, you will have a very tiny interval around L, which will give you an idea about L, or a sufficiently close approximation of L. Let's check out this example. So we need to prove that these two sequences are adjacent. Of course, the first one is the sum, so it's 1 over 1 to the power 3, so it's 1 over 1, plus 1 over 2 to the power 3, plus 1 over 3 to the power 3, etc. And Vn is equal to un plus 1 over n squared. So V1 is equal to u1, which is 1, plus 1 over 1 squared. V2 is equal to u2 plus 1 over n squared, etc. So to prove this, we need to prove three things to prove that these two sequences are adjacent. First, we need to have one of them is increasing, the other one, the second one is decreasing, and then the difference goes to 0. Let's try to find about un, if it's increasing or decreasing. Un plus 1 minus un is equal to the sum k going from 1 to n of 1 over k3 minus the sum k going from 1, to n plus 1, the first one, to n of 1 over k3. So which is equal to 1 over 1 to the power 3 plus 1 over 2 to the power 3 plus etc. plus 1 over n3 plus 1 over n plus 1 power 3. Of course, you don't need to write the sum as I'm writing it explicitly if you know already the answer, so you can write immediately the answer. But I'm writing it so you can understand if you have confusion with the sum symbol. So minus 1 over 1 squared plus etc. plus 1 over n squared, which will be equal to only one term because these ones will be cancelled, and then 1 over n plus 1 to the power 3 will be the remaining term, n plus 1 power 3, which is positive. Then un is increasing. What about Vn now? So Vn plus 1 minus Vn is equal to un plus 1 plus 1 over n plus 1 squared minus un minus 1 over n squared. And this is equal to un plus 1 minus un plus 1 over n plus 1 squared minus 1 over n squared, which is 1 over n plus 1 to the power 3 that we already found, plus 1 over n plus 1 power 2 minus 1 over n squared. Doing a common denominator, we will obtain at the end 1 over n plus 1 to the power 3 times n squared, and in the numerator we will have minus n squared minus 3n minus 1. in the denominator we have something that is positive, right? And in the numerator, voila, in the numerator we have something that is negative because it's minus n squared, minus 3n and minus 1. So the whole fraction will be negative. Then Vn is decreasing. So we need to prove now that the difference is going to 0. What about un minus Vn? Well, it's equal to un minus 1 over n squared, right? So the un terms will be cancelled. It will be equal to minus 1 over n squared, which is something that goes to 0 when n goes to plus infinity. Therefore, un and Vn are adjacent.